I did find out why my recording was screwed up yesterday. The hard drive was full. I had a full year's worth of videos saved on there, at least 2 a day. Just kind of let me know when you're good, Lily. Oh, all right. Yep. Okay, so this picture on the left says the graph of function g is shown below. Let h of x, I'll write it bigger if that helps you. Apparently it's Taco Bell day today or what? Says let h of x equal the integral from -1 to x, g of t dt. Okay, so that is basically similar to what we had up above, where -1 was the bottom number. It's not always the case, just for these examples, apparently. Evaluate h of 3. All right. Excellent. Emma. Emma, can you tell me what h of 3 means? What am I trying to do? Oh, excuse me. Maybe Emma can't hear me, or maybe her mic's messed up. Yep. Oh. That's no problem, Emma. I can't believe you even responded to me if you're driving. Who should I? Mandy. Mandy, can you tell me what h of 3 means? H's, yep, H is up there. Okay, so then what? Okay, so if I put 3 in place of x, what is that telling me to do? That's kind of what I was hoping you could. Oh, that was a bad 3. That was a great way to say it. It was a great way to say it. Yes. So I'm going to find the area underneath the curve from -1 to 3 from function g. And kind of the same thing. You'll get a lot of the same shapes. So I've got 4 by 3, 2 by 2, 2 by 2 again. So 16, 18. And I could put 18 square units if I wanted to. This one doesn't really have units. Or, I mean, yeah, it doesn't have any kind of units somewhat. All right, second one, it is virtually identical. I mean, like, there's nothing different on these at all. Once you understand what the accumulation function notation is, they're all the exact same. So h of -2 would mean, and I'll write it bigger if you can't see it. On this second one, h of x is the integral from -4 to x of f of t dt. Yes, yeah, that is possible. I really haven't ever seen that though. But yeah, I mean, there's no reason it shouldn't or couldn't be. So -4 way over here to, what were we doing? -2. This is kind of an annoying shape, but we'll go with it. So we've got 2 by 6, 1 by 1, which is 0.5, and we've got 1 by 2, which is 1. So h of -2 would be 13.5. Okay, now that first topic was definitely going to be the fastest here today. If anything, you know, the longest part would be for you guys to draw on it or something. Anybody have any kind of questions on accumulation functions? Okay, then I'll get to the next topic, which seemingly looks horrible. I will give you that. I'll give you a minute to write down what's in red, because that's the fundamental theorem of calc. It's actually the second fundamental theorem of calc, and I don't know why it's not labeled that way, but I'm trying to copy Khan Academy's labeling so that you guys don't get thrown off when you're, doing your work. So they have this section labeled the fundamental theorem of calculus. There's technically two fundamental theorem of calc. This is the second one. But in Khan Academy, they just refer to them both as a fundamental theorem of calc. And I'll wait till you get stuff written down till I describe it. And I'm actually kind of excited because I finally got my name drawn in the lottery for the vaccine. So I get to get my shot this afternoon at Park. And then that means I'm super excited because I get my second shot on March 26th. So I actually get to come back to school for most of the third trimester. So I'm pretty excited. I don't know if I ever told you guys why I'm teaching at home, but I have a couple of autoimmune diseases. And the way they treat autoimmune diseases is they basically give you medicine to shut down your immune system. And so a vaccine is pretty important for me. Okay, it's okay if you don't have those 5 problems written down yet. We're going to go through them together. Thank you guys. Yeah, I know, I'm pretty excited. It's totally a random lottery for basically all of teachers. So it's just, when your name gets called, you go. All right, so before I even unpack this, let's talk about what this means. Okay? The integral symbol is often going to be called the antiderivative. So most of you guys, if you think of something as kind of linear, I shouldn't use the word linear, in math, but like a hierarchy. Let's just say this is your function. A derivative, in terms of your brain, you can kind of think of derivative as going down a level, right? So you're finding rate of change. So in a hierarchy, you're going down a level. An antiderivative or an integral is the opposite. So that would be going up a level. That's basically trying to figure out what equation something came from. That means your original equation is the rate of change of something else. So you've got derivatives, antiderivatives. Well, if you were asked to take the derivative of an antiderivative, what should happen? Kayla, what should happen if you take the derivative of an antiderivative? Perfect. Nice answer. So derivative and antiderivative are opposites. They have opposite operational goals, and they cancel each other out. So if you're taking the derivative of an antiderivative, you're left with that. So that's what this whole red formula is, okay? Now the red formula is a little bit different, and I don't know, is red hard for you guys to read? Do you want me to change that color? I don't know how it comes across on streaming. On my monitor it's fine, but okay. So you'll kind of see this is called a definite integral, which is different than an indefinite integral. So when an integral symbol has numbers on, that was an accident. When an integral symbol has numbers on it, it's like finding the area under the curve. So it's basically only integrating from here to here. Well, you'll see that f of x is up top. And then the function here is g of t. So what actually happens is when you cancel out the integral symbol with a derivative, this function goes in place of that letter. So you get g of f of x. Now, because we are taking derivatives, we have to go by derivative rules. So if you take the derivative of something, then the chain rule also applies. So that's why we have the derivative of f of x as well. Now, it absolutely looks complicated. You will 100% see that the questions themselves are actually really easy. Let's start with number 1. So you're given g of x. Let's find g prime of x. So, Dane, do you remember what prime tells us to do? Like, what's the prime mean? Good. So the prime means to do the derivative. So the derivative of the integral is going to cancel out. But because I have a variable right there, that is going to go in place of t. So instead of this just flat out canceling out and 8 minus t being what's remaining, I'm going to have 8 minus an x in place of the t times the derivative of what I plugged in, which is 1. Now you'll see that this question asks us to find g prime of 1. So it's not d times x, but it's the derivative of x. Yep. So g prime of 1 would mean I would plug 1 in. Oh my goodness. Thank you, Melanie. Oh, no. You threw me off for a second when you said negative 1. I was taking the derivative of what I plugged in. I wasn't taking the derivative of that function. So if I was taking the derivative of 8 minus x, it would be negative 1. I was taking the derivative of what was plugged in. So g prime of 1 would be 8 minus 1, which is 7. And I know from your perspective, this feels ridiculously useless right now. It will have uses. Go ahead, Lily. Are you trying to ask something? Oh, okay. No, that's all right. Oh, no, that's fine. I do it all the time. Okay, I'll do number 4 with you. We'll go. I want to show you the different types that we're doing. So capital F of x is the integral from negative 5 to 3x of square root of 15 minus t dt, which that's a lot. There's a lot going on there. We are asked to find f prime of x, so that specifically means to find the derivative of this. The derivative and the integral symbol cancel each other out, but because there was a function there, I'm going to put that in place of the variable There. So my answer would be square root of 15 minus 3x. And then I'm going to multiply by the derivative of what was plugged in. So I'm going to tell you from past experience that it's going to be easier for you to learn how to do these problems before it clicks and makes sense what you're actually doing. Like, don't sweat it if this just feels a couple levels above your head. Because it's not, but it might feel like it at first. So don't sweat that for now. For right now, just kind of learn how to do the problems. Let's do 2. We'll do 2, and then I'll have you guys try 3, 5, and 6 on your own. I think there was 6. Yep. So let's do 2 together. The integral from 0 to x cosine of t dt. Find g prime of pi. Well, that means I have to find g prime of x first. Derivative of the integral. Plug in this function in place of that variable. And I know my function is just an x. So the bottom of it does not, Jessica. So this is a case of where I usually taught you guys how to do definite integrals right away. But both AP and Khan Academy do it a different order. And so it feels unnatural to me. And because you guys don't necessarily know what, like, it doesn't really necessarily click yet about these numbers. So I'll just say this number on the bottom doesn't matter at all. It seems so wrong, but it doesn't actually matter. It doesn't affect the answer. So g prime of x would be cosine. Instead of a t, I put an x. Multiply it by the derivative of what I plugged in, which, if you already know it's a 1, it's fine not to write that. G prime of pi would be cosine of pi, negative 1, would be your answer. Cosine of pi. Yeah, that helps. I do that myself. You answer your own question as you ask it. Why don't you guys try those 3 that are blank? See if you can come up with the answers. And 100% just be asking questions if you run into something. Yeah. Are you talking about the regular one or the minus 1 that I circled? Right here? That is the derivative of what I had plugged in. So because I plugged in a regular x, the derivative of x is 1. Yeah, if you wanted to, I could write it like this. Something like that. Yeah. You know, I 100% never even thought of explaining it like that, but that is still fully correct. And now that you pointed that out, I have no idea how I never spotted that. They are the same thing. They are the same thing. Since we haven't done a lot with integrals yet, the DT is just really throwing you guys off, which I get it. They are the same thing. That 100% is easier to do, isn't it? They mean the same thing. Delta means how much something changes. D means derivative. Yeah, because derivative means the rate of change, and delta is the change. So they're not like word for word the same. They represent same info, but they're usually used on different like variables or problems. I can't believe I never thought of doing that before. That probably makes it way easier to explain. I like that one. Okay, we're at 11:28. So I don't know how far you guys are. I'm assuming once you've got these figured out, they go fast. It's just more once you clicks. So derivative of g, I'm going to put x in place of every t. I really like this way now, actually. That makes it so much easier. I put an x in place of every t. So g prime of x would be 5x squared minus x times the derivative of x. G prime of 2, 5 times 4 minus 2 times 1, so 18. Question 5 is just f prime of x. It says where x is greater than 0, and it only says that because of the square root of x part here, because you can't have negative numbers in place of x. So that actually has nothing to do with how you approach the problem. It just has that as like a domain restriction. So they cancel out. I plug this in place of t. Bad arrow, but we'll go with it. So f prime of x would be square root 2 times square root of x times the derivative of square root of x, which is also going to be more work. So 2 root x times derivative of x to the 1/2 power would be 1/2 x to the negative half. This is actually going to 2 and 1/2 turn to 1. Square root of x times 1 over square root of x is 1. That's odd. Six. Two times a half is 1. X to the negative half means 1 over root x. So root x times 1 over root x cancels, and you have 1. Put cosine in place of t. F prime of x would be 3 cosine of x times negative sine of x, so negative 3 cosine sine. I don't know. How are we doing on these? Is there something up there? I mean, I'm fully kind of anticipating that once you figure out the patterns and the workings, they definitely are all the same. Unless you're confused on a step and then they all seem horrible. I mean, that's kind of how Calc works, which is rough. It seems like everything in Calc is very confusing until it clicks in your head how it's set up. And then they seem the same. Like they seem easy and they're all seem the same, no matter how complicated they make it look. Okay, last topic. There's no good title for this, but if you want me to put a title, calculus-based justifications. So that basically means it's going to be problems that combine pretty much anything we've learned throughout the year. And you have to use reasoning to figure out the answer, because there's nothing that's going to be straightforward, nothing that's going to be the same. I love these problems. I know some people hate these problems. I like them because they're all different. This is the graph of f. I like that start. Very straightforward. This is the graph of f. It's also a very plain graph. That's lame. Let g of x equal the integral from 0 to x of f of t dt. What is an appropriate calculus-based justification for the fact that g is concave up? Whoa. Well, they give you information about f, but then they ask you about g. So I guess this kind of is dependent on the question. Concave up. That's second derivative is positive. So I need to know the second derivative of g. So why don't I write down g and go from there? Well, the first derivative of g would be the derivative of the integral from 0 to x. So, shocking, that's what we just did, right? So that's how they're putting them together. Derivative of the integral cancels out. I plug x in place of t. So it's f of x times 1. F of x happens to be our graph. Okay, g double prime of x would be f prime of x. Okay, since we're just going from a picture, how do we figure out f prime of x from the picture? Does anybody, I'll just ask anybody here, does anybody remember what f prime looks like on a picture? Perfect. F prime of x from that picture would be our slope. So we need to know when the second derivative is greater, if, not when, if the second derivative is greater than 0. Yes, because the slope of our graph is positive. So that means g double prime is positive, which happens to mean concave up. So that's the calculus-based justification. Now these questions are going to be multiple choice for you. So obviously they're going to have it worded in some way or form, but I didn't want to go through multiple choice with you. I wanted to talk about how to figure out the answers. And technically this isn't something I need to teach you, but it's like, these are so strange when you just kind of get to them that most students get lost. Ask away if you guys have questions, unless this is not bad, but okay. I think I only have one more. I don't have one more. I have two more. It looks like I didn't erase that one. But I can stop wherever. I probably had this lesson made up for last tech semester when it wasn't on a Friday, so. Why don't you guys try this one on your own? This is the graph of f. Let g be the integral from 0 to x of f of t dt. So it's kind of like the last one. What is an appropriate calculus-based justification for the fact that g has an inflection point at x equals c? So there's your key words. You have to know how to figure that out. How do we figure out an inflection point? Down? Oh, really? Oh, weird. I just assumed the way it shared screens, yeah, sorry. Okay, so I wrote what you need to figure out. Technically, you should already know that. An inflection point is when second derivative is 0 or undefined. And looking at this picture, that shouldn't be any kind of undefineds. It also has to have concavity be positive and negative before or after. So try to figure that one out. Now that I'm doing this one, I see that it is very much like the last problem, and I didn't want them to be that similar. I mean, the question is obviously different, but okay. So because this was very similar to the last one, the slopes of our picture represent G double prime. And we were supposed to say, what's a way to prove that G has an inflection point at C? Well, going by our graph, the slope at C is 0. So that makes it a PIP, a possible inflection point. The slope before it and the slope after it alternate, negative to positive in this case. So that makes it an inflection point. and that would be the calculus-based reasoning. Okay, these were the 3 topics I had for you guys today. I'm actually impressed with myself that I got that all within before 11:45. I didn't want to have to keep you later. Now, so just as an FYI, so today there's just like a couple 3 assignments to do. And then I think yesterday there was a quiz. Quiz 1 was at the end of yesterday's homework, so hopefully you did that. Starting on Monday is when we're going to start working with the integrals a lot more. And so it's going to feel like you're going to get information thrown at you, but a lot of the information is similar to each other. So it's very, very much easier to learn than a lot of the information we had this week. So the second half of this unit feels like it goes a lot faster, but most students found it a lot easier. And so we're gonna get to our test on Friday, and I think really the only way to set it up nicely is so that we'll just do the test on Friday itself. You know, start at 11 and let you finish whenever. Is that what we decided before? Can't remember. I mean, it kind of seems like it makes the most sense. I could theoretically, no, Thursday night wouldn't be good. I don't remember the first test we took. It's all in Schoology. Is that what you're asking? The Schoology part? Oh yeah, right. It's not like that. These are all in Schoology. I don't have a full FRQ question like I did on the last test. Yes, Mandy, I can. You mean very top like this? Okay. Yeah, so this one doesn't have a full FRQ like the last test. But this one does have more questions where you can write out the work in the problem in Schoology. And I can't remember, you might not even need to turn in work on this one because the work is in the problem. I'll go through and double check, and I'll get you guys the outline for the test on Monday, so that if you want to start prepping early, you can. But basically, you're learning half of it next week. So I don't like that schedule, but I can't think of a better or fairer way to do it. So either way, this weekend, I guess the only work you should do is if you have work to make up. Otherwise, you should be able to have a pretty low-key calc weekend, because I know we have a lot of work next week. So I'm not going to try to like overload you with everything. So I guess thank you for coming. You guys have a good weekend. Yeah.